Hello everyone, my name is Nishant Srivastav and I am a student of B Pharma first year. My topic is motion in a straight line. Some topics included in motion. First, velocity. Velocity is the directional speed of an object in motion as an indication of its rate of change in position as observed from a particular frame of reference and as measured by a particular standard of time. Its dimension is Lt minus 1. Second, acceleration. It is the rate of change of the velocity of an object with respect to time. Acceleration is the vector quantity. The orientation of an object's acceleration is given by the orientation of the net force acting on that object. Here is the formula for velocity and acceleration. Velocity is equals to displacement upon time, and acceleration is equals to change in velocity upon change in time. Now the third one is distance. It is a numerical measurement of how far apart objects or points are. In physics or everyday usage, distance may refer to a physical length or an estimation based on other criteria. The distance from a point A to a point B is sometimes denoted as AB. Now, fourth one is displacement. A displacement is a vector whose length is the shortest distance from the initial to the final position of a point P undergoing motion. Now let's see the differences between distance and displacement. First one is distance is the length of the path traveled by a body while moving from an initial position to a final position, whereas in displacement is the shortest distance between the initial position and the final position of the body. Second is distance is a scalar quantity where displacement is a vector quantity. Third is distance measured is always positive, where displacement can be positive or negative depending on the reference point. Fourth one is the total distance covered is equal to the algebraic sum of all the distances traveled in different directions, where in displacement the net displacement is the vector sum of the individual displacements in different positions. Fifth, there is always a distance covered whenever there is a motion. In displacement, it will be 0 if the body comes back to its initial position. The unit of the distance is meter and the unit of displacement is also meter. Next, sixth is speed. In everyday use and in kinematics, the speed of an object is the magnitude of the change of its position over time or the magnitude of the change of its position per unit time. The formula for speed is distance upon time. Its dimensional formula of speed is Lt minus 1. So, let's talk about motion in a straight line. Motion in a straight line is called straight motion if the direction of a moving object is constant and the object is moving at a constant speed, then it is moving in a straight line. In this case, the object is said to be moving in a straight line at constant speed. Now there are two types of motion in a straight line. First is uniform linear motion and the second one is non-uniform linear motion. Now the simplest type of motion is uniform linear motion. In this type of motion there is no change in the velocity and direction of the object at any point throughout the motion and hence the acceleration is zero. Example, a car moving at a steady speed and a rocket traveling at a constant speed and a train moving at a constant speed. Now the second one is non-uniform linear motion. The type of motion in which the object travels with a varied speed is called non-uniform motion. This means that the object does not cover equal distances in equal time intervals and hence the acceleration will not be zero. For example, movement of an asteroid, a car coming to a halt and bouncing ball all cover unequal distances in a time interval. Now let's discuss the laws of motion. The first one is law of inertia. The first law of motion states that an object will remain in the state of motion and position it was in when it started unless an outside force is applied to it. For example, when the bus stops suddenly, people fall forward. Now the second law of motion is momentum. Newton's second law states that the acceleration of an object depends upon two variables, the net force acting on the object, and the mass of the object. For example, pushing a cart. It is easier to push an empty cart in a supermarket than a loaded one, and more mass requires more acceleration. Now, the third law of motion, action reaction motion. If an object A exerts a force on object B, then object B must exert a force of equal magnitude and opposite direction back on object A. For example, a swimmer pushes the water backwards with their hands, and in return, the water pushes the swimmer forwards, thus enabling him to go forward during swimming. Now, there are three equations of motion in a straight line. When a moving object moves in a straight line, its trajectory is described by a set of simple mathematical equations. These equations can be used to predict the future position of an object, given its current position and speed. First one is v is equals to u plus at. Now the second equation is s is equals to ut plus half at square, where s is speed and u is initial velocity, t is time, and a acceleration. Now the third one is v square is equals to u square plus 2as, where v is final velocity, u is initial velocity, and a acceleration, and s is speed.